Over the course of this cruise, two groups have been collecting samples to study dissolved trace metals in the ocean.
So microbes need certain essential nutrients. We think of things like phosphate, nitrate, silica. And out in the open ocean, many of these nutrients become really low in concentration. In order to acquire these nutrients, you also need things like trace metals, which we study in our lab. The trace metals actually allow the phytoplankton to acquire these macronutrients of phosphate and nitrogen. And so out in the open ocean, these nutrients, the trace metals, can be in vanishingly low concentrations, say 1,000,000 times lower concentration than the macronutrients of phosphate and nitrogen, which we think a lot about in coastal waters as being limiting nutrients and having eutrophication driven by wastewater, which is coming from human beings and cities. And so the coastal waters are limited oftentimes by phosphate and nitrate. Out in the open ocean, it's a very different story. And in fact, iron becomes a limiting nutrient in many cases.
Zhongmi Li from the Massachusetts Institute of Technology is on board to collect iron samples.
Iron is one of the most important trace metals for microbes. So microbes need iron to do the photosynthesis and for nitrogen fixation, which is transforming nitrogen gas to nitrate, which is the form they can actually access and use. So what I'm doing on this cruise is to measure iron concentrations along the transect and also to find out the source of iron by measuring iron isotope ratios. So each source of iron, such as dust or sediment flux or hydrosolvent flux, they have characteristic isotope ratio. So by measuring isotope ratios along the transect, I can tell how much of iron has been supplied by this source or that source.
Tyler Geffret from Max Saito's lab at the Woods Hole Oceanographic Institution will explain a bit about what this group is on board to study.
So just as we need vitamins, phytoplankton, microbes need vitamins as well. And vitamin B12 is a very important micronutrient that's needed by many phytoplankton. Vitamin B12 just so happens to have a cobalt center, and cobalt is one of the trace metals that we study in our lab. Because what we're studying, the trace metals are in such low concentration, it's really easy to contaminate for them. And for that reason, we have to work inside of a bubble. And the bubble is just a bunch of plastic sheeting, and we construct this bubble when we get on board the ship. And we filter all the air coming into the bubble with HEPA filters. And so after a few days, the filtered air is very clean. It's blowing out all the dirty air from the bubble. And that's where we have to bring our samples in to process them. So you've seen the CTD that's used currently for most of the other work on board. We use a very similar CTD, except that ours is trace metal clean. So we're able to sample without the risk of contamination. We bring our bottles inside of that clean bubble in order to process them.
What about the particulate trace metal fraction?
So the other half of the story is the particulates. And for this we deploy pumps to a specific depth, and we sample, say, 1,000 liters across a filter. And we process that filter and look at the trace metals that are in the live cells, the dead cells, all the marine snow, the settling organic matter that's coming to these depths. And that closes the cycle, looking at these very important trace metals and how they're involved in life and the cycling of these metals in the world's oceans.
Tomorrow is our last full day of operations before we finish our steam to Rapa Nui. Keep following us for the next few days.